What is power factor correction using capacitors in AC? Imagine trying to push a heavy swing back and forth. If your effort is out of sync with the swing, you waste energy. That's similar to what happens in electrical systems with inductive loads. When devices like motors or transformers operate, they create a lag between voltage and current. This lag causes the power factor to drop below 1, meaning not all the power supplied is used for work. Instead, some of it just circulates back and forth, called reactive power. This reactive power doesn't do any useful work but makes the system less efficient. To fix this, engineers add capacitors to the circuit. Capacitors store electric energy in electric fields and releases it quickly. When placed in parallel with inductive loads, they supply reactive power that leads the current. This leads to a balancing act where the capacitor's reactive power cancels out some of the reactive power from the inductors. As a result, the overall reactive power decreases, and the current becomes more in phase with the voltage. This means the power factor improves, moving closer to 1. When the power factor gets better, the system uses less current to deliver the same amount of real power. This reduces energy losses in wires and transformers, and it can help avoid penalties from utility companies for low power factors. It also makes voltage levels more stable, which benefits all connected equipment. The size of the capacitor needed depends on the amount of reactive power the load creates. Engineers calculate the reactive power from the inductance of motors or transformers and then select a capacitor with the right capacitance to offset it. This process involves understanding how inductance and capacitance influence the phase difference between current and voltage. Inductors store energy in magnetic fields, causing current to lag, while capacitors store energy in electric fields, causing current to lead. By adjusting the capacitance, they balance these effects to improve efficiency. In practical terms, power factor correction capacitors are often installed in factories or large buildings with many motors. They can be fixed, providing constant correction, or switched automatically depending on the load. Proper sizing and placement are essential to avoid overcorrection, which can cause the current to lead the voltage too much and create voltage instability. In summary, power factor correction using capacitors in AC systems is a way to make electrical systems run more smoothly. It reduces unnecessary reactive power, aligns current and voltage better, and cuts energy waste. This process ties directly into the principles of inductance and capacitance, showing how magnetic and electric fields influence the flow of current and voltage in alternating current circuits.